Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to a new school year. Welcome to Algebra 2. This is Lesson 1, Successive Differences in Polynomials. Okay, so the classwork opening exercise says that John noticed patterns in the arrangement of numbers in the table below. So pause the video here, take a look at these arrangement of numbers, see if you can find a pattern. And if you think you've got it figured out, unpause the video and check and we'll discuss it. Okay, so in looking at this, sometimes it's easier to work backwards. So let's start with this here. I see a 2 here, and I see a 2 here, and I see a 2 here. Well, if you look, 5.8 plus 2 equals 7.8. 7.8 plus 2 equals 9.8. 9.8 plus 2 equals 11.8. Okay, so there's something going on there. And if I look at this, 5.76 and 5.8 looks to be an addition as well. So if I do 5.76 plus 5.8, does it give me 11.56? And it does. So this plus this equals that. And does it continue? For it to be a pattern, it's got to be repetitive. 11.56. Now I'm going to add 7.8 to see if that gives me 19.36. And it does. So then this gets us to here. And then if I do it again, plus 9.8, I get 29.16. So that seems to be what's happening here. We're just adding. So the difference, this is a difference. 11.56 minus what gives us that? So then 29.76 plus 11.8 is 40.96. So this gave us that. Okay, so for starters, we're starting out with numbers 2.4, 3.4, 4.4, 5.4, 6.4. They're just adding 1. So we're given numbers. Okay, so we'll just say that, well, here's the starting number. All right. And how did we get from 2.4 to 5.76? How did we get from 6.4 to 40.96? These values are increasing. This is more than double that. So it went from 5 to 11, it increased by 5.8, then it increased 7.8, then it increased by 9, then it increased by 11. So it's not just adding the same amount every time. So we have to do something to get these numbers. And we're trying to figure out what this is. And you might want to use your calculator to figure this out and take a number and divide by the other. So you say 5.76 divided by 2.4 and see if there's a common multiple. And I got 2.4. Will I get 2.4 when I divide 11 by 3? Doesn't look like it. 11.56 divided by 3.4 gives me 3.4. So there's a pattern here. 2.4 times itself is 5.76. So it looks like we're squaring the first number. So let's just make sure that's true. So to go 4.4 squared, and that gave us 19.36. We're looking good. 5.4 squared gives us 29.16. And I'm assuming that 6.4 squared is going to give us 40.96. And sure enough, so this is the number squared. So this is the square. Okay. So then once I find the square of the number, these are common differences. So this is what we are going to call in this lesson the first difference. Okay, so this is the first difference. Difference of 5.8, difference of 7.8. We didn't get the same difference every time. It's increasing by 2's. But then when we take the difference here, we got a difference of 2, a difference of 2. So now we're just saying plus 2, plus 2, plus 2. So this is what we're going to call the second difference. Okay, and there we go. And it says, assuming that the pattern would continue, he used it to find the value of 7.4 squared. Okay, explain how he used the pattern to find 7.4 squared and then use the pattern to find 8.4 squared. All right, so what he would have to do is, if he's assuming that 7.4 is going to be the next number, and this is increasing by squaring it, what he's going to do is say, okay, well, let's work backwards. And so if I put a 2 here, this is going to be 13.8. Okay. So if I add 13.8, see, I've got this stretched out a little too much. Let me rewrite this so they line up. All right, so I want this 2 to line up here. So I want the 2 right here and then going over and then a number in between. So let's slide that over a little bit. Okay, and then this would be 13.8. Well, 29 plus 11 gave us this. So 13.8 added to 40.96. So if I just say plus 13.8, that gives me a value of 54.76. So this number here would be 54.76. So then if I check that, 7.4 squared should equal that. And it does. So what did he do? Well, he added 2 to the first difference and got 13.8, and then added that 13.8 to 40.96, which is the first difference added to this previous number. So then it says, explain how you use the pattern to find the second, and then use a pattern to find 8.4. Well, if we're going to continue this pattern, then this is going to be a 2 again, and this is going to be 15. Let me do it in a different color. Okay, so if I go to purple now, so this is going to be 2 again, and that is going to give me the number 15.8, adding 2 to this first difference. So 15.8 is going to get added to 54.76. So if I just say plus 15.8, that is going to give me 70.56. And that should be 8.4 squared. And if I check that, 8.4 squared is 70.56. Okay, so there is, and that's how you would use this pattern to find the square of a number. Okay. And how would you label each row of numbers in the table? Well, I've already done it. You're given a number, you square it, you take the first difference, and then you take the second difference. And so you do that until you find the same difference every time. Okay, so discussion, it says, let the sequence a sub 0, a sub 1, a sub 2, a sub 3, continuing forever, be generated by evaluating a polynomial expression at the values of 0, 1, 2, 3, and continuing on forever. The numbers found by evaluating a sub 1 minus a sub naught, a sub 2 minus a sub 1, and a sub 3 minus a sub 2, and continuing this fashion form a new sequence, which we will call the first differences of the polynomial. The differences between successive terms of the first difference sequence are called second differences, and so on. Okay, so what they're saying is if you get the first difference right here, and then you take the difference of the first difference, and that is the second difference. Okay, the difference between successive terms of the first differences sequence are called second differences, and so on. If I didn't get a 2, 2, 2 here, if these were still different, then I'd look for a third difference, and so forth. All right, page 2, example 1 says, what is the sequence of the first differences for the linear polynomial given by ax plus b, where a and b are constant coefficients? So what we're focusing on here is plugging values in for x starting with 0. And then you put a 1 in, and you put a 2 in, and so on and so on. So if I put a 0 in for x, it'd be a times 0 plus b. All right. So if I do that, Let me just start a set. If I plug in 0 here, a times 0 is 0. 0 plus b is just simply b. So my first term will be b. Then if I plug in a 1, I get a times 1, which is 1. I'm sorry, which is a. A times 1 is a. A plus b is simply a plus b. And then if I put a 2 in, it'd be 2 times a, or 2a plus b. And then once you do a few of them, you see a pattern, and you're pretty much done. So if I plugged a3 in now, it'd be 3a plus b, and 4a plus b, and 5a plus b, and so on, and so on, and so on. Oops, let me erase this. It doesn't stop, so you want to put a comma and dot, dot, dot to show that this goes on forever. Okay, so there's the first several terms. There's the sequence. And so the first term, what you do is you take the a plus b, a times 0 plus b, and you subtract the b, and that gives you a. For the second term, you then take the 2a plus b minus a plus b. So to get the first term, I took the second term minus the first term. For the second term, I'm going to take the third term minus the second term. So it's going to be 2a plus b minus a plus b. And when I do that, 2a minus a is 1a, and b minus b cancels, and I get a. So for the third term, we are going to take the fourth term, 3a plus b, and subtract. Sorry, my pen got wacky on me. And subtract the third term. And 3a minus 2a is a. B minus b is 0, and we just get a. And as you can probably see now, you're seeing a pattern. To get the fourth term, we're going to take the fifth term minus the fourth term. So it's going to be 4a plus b minus 3a plus b. And that is going to equal a as well. And this continues on and on and on and on. So the first difference of the sequence is going to be a, comma, a, comma, a, comma, dot, 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 dot. All right, so there's our set. That is the first term difference of this linear polynomial. All right, so now it says, what is the difference of this? What is the sequence? What is the sequence of second differences for ax plus b? Okay, well, if the first difference is a repeated, to get the second, you're going to say, well, the first difference is going to be a minus a, which is 0. And the second is going to be the third minus the second, a minus a, which is 0. And the third is going to be the fourth term, which would have been a minus the third term, a, which is 0. So the sequence of the second difference for a linear term is just simply 0, comma, 0, comma, 0, comma, 0, dot, 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 forever and ever and ever. Okay, so the sequence of the second difference of a linear polynomial is 0. And finally, example 2, find the first, second, and third differences of the polynomial ax squared plus bx plus c. Okay, so this is a quadratic, by filling in the blanks in the following table. Okay, so here is the polynomial standard form. If we substitute 0 in for x, we get a times 0 squared plus b times 0 plus c. Well, everything cancels except the constant c. And then when we substitute in a 1, we get a times 1 squared, which is 1. A times 1 is 1, plus b times 1, which is b. So we get a plus b plus c. I think I said 1 here. A times 1 is a, not 1. So we get a plus b plus c. So the first difference between these two, if I subtracted c from a plus b plus c, well, then I'm just simply going to get a plus b. And then when I subtract c from c here, I get nothing. 2b minus b is b, and 4a minus a is 3a. So I get 3a plus b. 9a minus 4a is 5a. 3b minus b is b. C minus c cancels. 16 minus 9 is 7a. 4b minus 3b is 1b, and c minus c is 0. 25 minus 16 is 9a. 5 minus 4 is 1b. So the first difference was a plus b, 3a plus b, 5a plus b, 7a plus b, 9a plus b. They are not the same, so you continue. Then to the second difference, 3a minus a is 2a. B's cancel. 5a minus 3a is 2a. B's cancel. 7a minus 5a is 2a. B's cancel. 9a minus 7a is 2a. B's cancel. So the second difference was 2a, 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 2a. And then finally, the third difference is going to be 2a minus 2a, or 0, 0, and 0. Okay, so there is the first, second, and third difference of a polynomial, actually a quadratic in this case. Okay, page 3, example 3. Now it says to find the second, third, and fourth differences of a cubic, ax cubed plus bx squared plus cx plus d, by filling in the blanks of the following table. So they've already done the first one for us. So if you look, the d's cancel, and the 8 minus 1 is 7, 4 minus 1 is 3, 2 minus 1 is 1. So they did the first difference for us. And we're just going to continue with the second difference. So simply 7a minus a, which is 6a. 3b minus b, which is 2b. And the c's cancel. 19 minus 7 is 12a. 5 minus 3 is 2b. 37 minus 19 is 18a. 7 minus 5 is 2b. 61a minus 37b is 24, if I'm doing this correctly, 24a. 9 minus 7 is 2b. The third difference is 12 minus 6, which is 6a. The b's cancel. 18 minus 12 is 6a. The b's cancel. 24 minus 18 is 6a. The b's cancel. Fourth difference, since they're the same, is going to be 0. Okay, so I'm seeing a pattern here. Let's go back and take a look. So first we started off with a linear function, ax plus b. So that is of degree 1, if you will, ax to the first plus b. So whenever you have a polynomial degree 1, then the number of differences 1 more than the degree will be 0. So degree 1, second difference, 0. A quadratic is degree 2, so it's the third difference, that was 0. And then we did a cubic, degree 3, and it took us 4 differences to get to 0. So there's a pattern there. So if it was ax to the fourth, then it would be the fifth difference. That would be 0. So example 4 says, what type of relationship does the set of ordered pairs x comma y satisfy? How do you know? Fill in the blanks in the table below to help you decide. The first differences have been computed for you. Okay, so here they gave us x, y values, 0, 2, 1, 1, 2, 6, and so on. So as you can see, this is getting large pretty quick. And then they took the first difference of these x comma y's. So 1 minus 2 is -1, 6 minus 1 is 5, 23 minus 6 is 17. So they're finding the first difference of the y value, or the value of the relationship when x values are substituted in. Okay, so 6 minus 1 is 5, 23 minus 6, 17, 58 minus 23, 35, and so on. So the second difference, 5 minus a -1, careful, is 6. 17 minus 5 is 12. 35 minus 17 is 18. And 59 minus 35 is 24. Third difference, 12 minus 6 is 6. 18 minus 12 is 6. 24 minus 18 is 6. Okay, so since the third differences are constants, the pairs could represent a cubic relationship between x and y. So this could be, what type of relationship? I would say possibly, possibly a cubic relationship. Since it took 3 differences to get it to be the same, and therefore the fourth difference would be 0. So this looks like it could be a cubic relationship. Okay, we're on page 4. Now it says to find the equation of the form y equals ax cubed plus bx squared plus cx plus d. So it's a cubic. That all ordered pairs xy above satisfy. Give evidence that your equation is correct. Well, if you go back to this page here, our third difference is 6a, 6a, 6a when we do it in standard form. But then we were given a set of values, 0, 2, 1, 1, 2, 6, and our third difference became 6. So we can set our third difference equal to our third difference to find our a. So the first thing I'm going to do is say, well, what is this doing? 6a equals 6. So if I divide both sides by 6, then I get a equals 1. So I know that a is 1. Then if I come back here, and I then realize that I have the point x comma y, 1, 1, and 2, 6. So if I have the point 0, 2, this first point here, right here, 0, 2, okay, and 0, 2 is going to equal, it satisfies the equation. So when x is 0, what would happen up here? Well, it became d. So when x was 0, y was d. And therefore we see that we get the point 0, d. And therefore our d is 2. Okay, so we have a equals 1, d equals 2. So that takes care of this and this, but we just don't know our b and our c. So we're going to take that formula that we used on the last page, our values. We have the point 1, 1. X is 1, y is 1. So when I come over here and I plug in x as 1 as y as 1, so now I'm going to use the point 1, 1. And so x is 1, so that would be a times 1 cubed plus b times 1 squared plus c times 1 plus d equals 1. So here's my x, here's my y. All right, so I'm going to simplify this now. I know that a is 1, so we're going to get 1 equals 1 times 1 cubed, or simply 1, b times 1 squared, or simply b, c times 1, which is c, and D is 2. So then we get this equation. So we have y equals x plus b plus c plus 2, where x is 1. Okay, so far so good. So then I'm going to go on to the next point, and it is the point 2, 6. Okay, and that is going to give us 8a plus 4b plus 2c plus d. When x was 2, we got 2, 6. So now I'm going to come back over here, and just to explain it, I'm going to put the point 2, 6 in here. And then I'm going to go back, and we got 8a plus 4b plus 2c. So I'm going to write that 8a plus 4b plus 2, plus 2c plus d equals our y, but our y is 6. Well, let's put y for starters. Let's put the y. And then I'm going to substitute in. So y is 6. X is going to be our 8. Okay, so if a is 1 and x is what? So it's a times x, which is 2 cubed. So x is 2, y is 6. So if I put so our a is 1. We've already found that out right here. So it's 8 times 1, or simply 8. Plus, we don't know b, so I'm going to put 4b. We don't know c, so I'm going to put 2c. And d was 2. So now we have these two equations. All right. So now we're going to use substitution. So we want something to cancel out. So we want either the b or the c to cancel. Those are the two things we don't have. So if I multiply this c by 2, I'm going to get 2c. And then we can subtract. So that's what I'm going to do. So I'm going to now take this. So now we're taking, we're solving by substitution. So I'm going to multiply this side by 2. And that's going to give me 2 equals 2 plus 2b plus 2c plus 4. All right. And then I'm just going to move that over here underneath this. And then we're going to subtract. So 6 minus 2 is 4. 8 minus 2 is 6. 4b minus 2b is 2b. And 2c minus 2c cancels, and 2 minus 4 is -2. So I can now solve for b. 4 equals 6 minus 2, which is 4 plus 2b. Subtract 4 from both sides, 0 equals 2b. So therefore, b equals 0 divided by 2, or 0. Okay. So now I know b. So I know a is 1. B is 0. So I'm just going to rewrite all of these. A equals 1. B equals 0. Still need to find C. And D equals 2. So how do I find C? Well, all I have to do is plug this 0 into this equation without multiplying by 2. So I get 1 equals 1 plus B plus 0 plus 2 to show all my work. And so 1 equals 1 plus 2, or 3 plus B. Subtract 3 from both sides, and we get b equals -2. All right. All right. So what do we have? If we're using this formula, and I ran out of room a little bit, so I'll kind of put it up here in line with this, I'm going to get y equals, a is 1, no need to write it, x cubed, plus b, whoops, didn't mean to erase so much, x cubed, okay, plus b times x squared. Well, b is 0, so 0 times x squared is nothing, so the quadratic portion of my equation is gone. C is -2, so it's going to be -2x, and d is 2, so it's +2. So this is the quadratic, no it's not, this is the cubic that represents these point values. And I could plug any one of those in and it should be true. So let's do that. Let's plug in 4 and see if we get 58. So if I plug in 4 here, y equals 4 cubed minus 2 times 4 plus 2. Y equals, well, 4 times 4 is 16. 16 times 4 is 64. Minus 8 plus 2. Well, 64 minus 8 is 56. Plus 2 is 58. And if I go back, I have 58. Okay, so there is the equation for that set of values. All right, so that kind of winds it up. Review this relevant vocabulary here. There's a lot of them, so I'll leave that to you. Review the relevant vocabulary, and that's the end of this page. All right, page 5 brings us to the end of the first lesson of Module 1 in Algebra 2. Go do your problem set.